We are continuing 10.3. This is called Gaussian elimination, named after the mathematician who founded it. In your directions yesterday, you may have noticed it said to use this to solve, but that is what we did yesterday. So we used the elementary row operations in order to solve. That is the Gaussian elimination. And then today we're going to identify certain forms that you can put these in. So it's called REF, and which is row echelon form. And then you have the reduced row echelon form, which is the RREF. And then there are certain ways to classify which form it is in. Okay, so we're going to read through those conditions. So a matrix is in row echelon form if the following conditions are met. So the first one is that you have the first non-zero number in each row. Reading from left to right, that has to be a 1. And that is called the leading entry. Okay, and then the leading entry in each row has to be to the right of the leading entry in the row immediately above it. Okay, and then the last thing is all rows consisting entirely of zeros are at the bottom of the matrix. Okay, so you guys didn't see that yesterday because we were working with systems that only had one solution, but we are going to talk about other types of systems today. So when you have a non-zero number in each row, left to right, okay, that leading entry, it's like you have them all to the right here, which is some of what we saw yesterday. So all of those were in the row echelon form, but then we had other numbers above. I'm just going to make these up. Okay, so the leading ones are always going to be to the right. They can even skip a row, which we'll see in some of the examples. But if it is reduced row echelon form, then not only does it satisfy the above conditions, it also has to have every number above and below each leading entry is a 0. Okay, so above and below, it would be a 0. So with what I had here, you would have to have something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so you'd have zeros above the 1, zeros above and below. This one would be below. And then sometimes you'll have a row of all zeros, okay, and that has to be at the bottom. So we're going to look at these matrices and label what form it's in, if it's in any form at all. So it might not be an REF or RREF. Saying that always makes me sound like a seal because I always go RREF. I'll make you guys say it. Okay, so observe the matrices below. So let's look at this first one. Okay, they tell you below that the leading ones do not shift to the right. So let's highlight those. So you have the leading 1 here, but then in this row, the first 1 you get is here. See how that's to the left instead of to the right? That's why it's not in that form. Okay, so the leading ones do not shift to the right because this one is the left. So we would say that is not in REF. And if it's not in REF, then it can't be in the reduced either. Okay, so this does not satisfy condition number 2. Okay, and that's that the leading entry in each row is to the right of the one above it. So if you look above it, this should be to the right of that. Now let's highlight the leading ones in this matrix. So the leading one in this column is here. This is the leading one here. This is the leading one here. Okay, so they are to the right. Okay, the first non-zero number in each row is a 1. Okay, so we have that. And any row of zeros, that's going to be at the bottom. So this would be REF. It's not in the reduced form because to be in the reduced form, you need zeros above the ones as well, which we do have in this one. Okay, so if we look at the ones in the last one, you are going to have above and below zeros. Above and below zeros. Above and below zeros. They are to the right there, so that satisfies all your conditions. Okay, so it satisfies conditions 1 through 4. Okay, this one only satisfies 1 through 3. Okay, and then I told you I edited this year to do the fill in the blanks, but then this moved up. It really should have been on the next page. So we can put a matrix in row echelon form using the elementary row operations. That's what we did yesterday. Okay, and then it says here's a systematic way for which we can convert a matrix into REF. And actually, I taught you that yesterday. Okay, so we're going to review that process. Okay, so we're going to start by obtaining, do you guys remember from yesterday what our first step is? What are we going to obtain first? A 1, yep, where? Yeah, great. Okay, so you have that 1 in that upper left corner. Okay, so it's the row 1, the column 1. Okay, and then once you do that, once you have the 1, what do we find next? Yep, we find the zeros below that 1. And we will always want to use that row that we got the 1 in to find the zeros. So what we do is we add the appropriate multiples. Remember, we do the opposites. So we do the appropriate multiples of row 1. So once you get the 1 in row 1, you're using that to help you find the zeros. And then that process repeats. Then you obtain a leading 1 in the next row, and then you do zeros below that. So instead of multiples of row 1, once you do it in row 2, then you do the multiples of row 2. Okay, and you just continue that process until your matrix is in REF form. Now, at each stage, you want to make sure that the leading entry is to the right. Okay, so at each stage, we just make sure that every leading entry is to the right of the leading entry in the previous row, and we can rearrange the rows if we need to. So if you have a 3 by 4 matrix, which is what we were working with yesterday, then the first thing you're going to get is this 1, then you'll get the zeros below. Then you will get this 1, then you will get the 0 below that, and then of course, the final thing is to get a 1 here, and then your matrix will be in REF form. Now, the blanks here are just representing any numbers there. So once an augmented matrix is in that row echelon form, that's when we can use back substitution. which we did yesterday, and that is called the Gaussian elimination in honor of its inventor, the German mathematician C.F. Gauss. So when you are solving using that system, this is really just a review of what we did yesterday. We put the system in an augmented matrix, then we use those elementary row operations to put it in row echelon form, and then we can solve using back substitution. Okay, so that is exactly what we did yesterday. Okay, so today we're going to start by doing the augmented matrix. Okay, so remember for the augmented matrix, you are just writing the coefficient from left to right. Okay, so I just did the first two rows. You go ahead and do the last row. All right, and then Nina, what'd you write for your last row here? -6, 1. Great. Okay, and I said this yesterday, I'll keep reminding you guys that one of the keys to being successful with these is just writing an organized matrix, like keeping these in line, or else it's hard for your brain to process like which one is being added where. Okay, so our first goal is to get the 1. Remember how we got the 1 yesterday? What did we always do? Yeah, multiply by the reciprocal. And this one actually works out really nicely because everything is a multiple of 11. So you just have to write 1 over 11 times our 1. That's the only thing we're changing. Okay, so then if I multiply by 1 over 11, I'm dividing by 11. So I get 1, 2, -1, 2. Okay, and you can decide if you like writing that one in first and then filling in the rest of the matrix. Some people like writing what's not going to change first, so you'll find your own style and do that. Okay, and then after we get the 1, the next thing we want to do is get zeros below it. Okay, so we're going to start with multiplying, and when we do the multiple, because we got the leading 1 in the first row, that's what we want to use. So if I'm trying to undo the 7, I just multiply by the opposite. So the opposite of 7 is -7. So I'm going to multiply row 1 by -7. I'm going to add that to row 2, and then I'm going to place my result in row 2. Okay, and then will you guys do that, do that second one? Oh, okay, so as you're doing this, like you should be saying in your head what you're multiplying, right? So this is -7 plus 7, that's going to give us the 0. This would be -14 plus 14, that's going to give us the 0. 7 plus 5, we get 12, -14 minus 10, -24. And if at any point you need to write some of that out, that is fine. Okay, but you should be saying those two yourself just to make sure you're doing that mental math correctly. Okay, now after that, normally what we do is we get the 0 here, which you can absolutely do. And once you get the 0 here, you might notice something. I noticed right away, see how you got 2 zeros here? That doesn't normally happen. So if you have the 2 zeros here, do you guys see how in row 3 you want the 2 zeros? Okay, so I would switch those rows, and like I said, I noticed it, so I switched them at this point. Some of you are probably not going to notice it until you get to the next step, but then you're going to see if you got rid of this first, that's fine. Then you'd see that you had like a 0 and a 1, and then maybe then you would switch, or this might have changed to something else. It just depends on what your process was. Okay, but we're going to go ahead and we're going to switch those. So because we notice the 2 zeros here, and that's what we need in row 3, we're just going to flip-flop row 2 and row 3. And it doesn't matter to me if you like put this here and then start with the matrix, or if you want to put that on the next line, that's fine. Okay, so row 2 is going to be -6, 1, 58, -51. And then row 3 is our previous row 2. And then row 1 is going to stay the same. All right, and then from there, now we can make this a 0. So if we make that a 0, it's always the opposite of that leading 1 here. Okay, so we're going to do the opposite of -6. We're going to multiply that by row 1. We're going to add that to row 2. We're going to put that in row 2. Okay, so I want you guys to go ahead and do that. Okay, so 6 plus -6 is 0. This would be 12 plus 1 is 13. Okay, -6 plus 58 is going to be 52. Okay, 12 minus 51. See, for me, I might want to write that out. Okay, so I know it's going to be a negative. So if I minus 10, I have 41. If I minus 2, I have 39. So -39 would go here. Okay, and then from there, now we can get the next leading 1. So we have 1, 0, 0. So now we want to make this 13 and a 1. How are we going to do it? Yep, we're just going to multiply by that reciprocal, so 1/13. And we get lucky again. They're all multiples of 13, right? So you have 0, 1, 52 divided by 13 is 4, and then -39 divided by 13 is -3. All right, now I want you guys to do your last step. And then I did actually put room on the next page for you to do the back substitution. If you want to do it all on this page, you can just have that room, okay? Okay, so you have 1, 0, 0, 1, 0. So the next thing we want to do is get what? So we have the 1, 0, 0, 1, 0. What do we need now in this row? A 1 where the 12 is. Okay, so we're going to multiply by the reciprocal. So 1/12 times row 3. Okay, so divide by 12. Okay, and then I have 1, 2, -1, 2, 0, 1, 4, -3. Okay, so now this is in REF. Okay, so that means we can do back substitution. Okay, so if it's in REF, we're going to use back substitution to solve. I'm going to do it on the next page. Okay, so when you're doing the back substitution, you're going to be using the equations. Okay, so we're going to take this matrix and we're going to write the equations from that matrix. Okay, and then I'll just write the matrix up here for you so you guys can see it. Okay, so we had 1, 0, 0, 2, 1, 0, -1, 4, 1, and then 2, -3, -2. All right, so the third row tells us that z is equal to -2. Okay, the second row is y plus 4z equals -3. So y plus 4 times -2 equals -3. Okay, so if this is -8, we're going to add 8 to both sides. Okay, and then our first row is x plus 2y minus z equals 2. Okay, so x plus 10 plus 2 equals 2 minus 12, x is -10. All right, so your final answer is just written as a coordinate, so -10, 5, -2. Okay, that is your solution. All right, so we put the matrix in that reduced echelon form. Okay, but if we put it in reduced row echelon form, so if we put that in the RREF, then we don't have to use back substitution. All we have to do to get the RREF is first put the matrix in REF, which we did. Then we're going to obtain zeros above each leading entry. Okay, by adding multiples of the row containing the entry to the rows above it. So what that means is the row containing that entry is if you're trying to make a 0 in like column 2, you got to use that leading 1 in row 2 in order to do it. So you start with the last leading entry, you can work up. And then this process is called Gauss-Jordan elimination. So in the final step of the Gauss-Jordan elimination, your matrix is going to look like this, which is really nice because then you're going to have just x equals a number. See how you would just have x? You wouldn't have anything for y or z. And then this row would be y equals a number. And the last row would still be z equals a number. So you would just be able to pick that out right away. So we're going to take the matrix that we were just working on from example 1, and we're going to continue that process to put it in reduced row echelon form. Okay, so the row echelon form matrix that we were just working with, we wrote right here. Okay, we're going to start with that, the 1, 0, 0, 2, 1, 0, -4, or -1, 4, 1, 2, -3, -2. Okay, so we have the 1, 0, 0, the 1, 0. What we want to do is we want to make this a 0. Okay, so if we're going to make that a 0, do you guys have any ideas of what operation we want to use there? So we want to make this a 0. So what row should we be multiplying by? Row 2, yeah, and we're going to multiply row 2 by -2, because then -2 plus 2, that's going to make 0. So we're going to add it to row 1, and it's going to replace row 1. Okay, so my last 2 rows are going to be the same. Okay, so what's nice about this, if you are using this row, is it's not going to affect what you've already done, because -2 times 0 is still 0. So 0 plus 1 is 1. -2 plus 2 is 0. -8 plus a -1 is going to be -9. A negative times a negative, that's +6. 6 plus 2, 8. So what I'm saying out loud to you is what you should be saying in your brain as you're doing this on your own. Okay, now there's a couple different ways you can do the next step. And I feel like we're ready to do a double step, okay? So yesterday when we did this, first we would make this a 0 and write out the matrix, and then we'd make this a 0 and write out the matrix. But because we're getting 2 zeros here, I'm going to show you how you can do that. Really, it's one step, but you're going to be doing 2 separate things. So basically, you'll only need to write out the matrix once instead of twice. Okay, so you're going to get zeros above the 1 in column 3. I was going to say you can, but then I started to say you get. So you get to do this in one step. Okay, so you just don't have to write out the matrix twice. Okay, so what we do is we put the first operation on top, we'll put the second one on the bottom. So you can still do it like one row at a time. So if we want this to be a 0, we want to multiply the third row by the opposite. It's the third row because they're in this column together. Okay, that's where the entry is. So we're going to multiply row 3 by 9. We're going to add it to row 1. and we're going to put that in row 1. Okay, so let's just do that step. So 9 times 0 plus 1 is 1. 9 times 0 plus 0 is 0. Okay, that's why you want to use this row so these don't change. Okay, and then 9 plus negative 9 is 0. 9 times negative 2 is negative 18. Negative 18 plus 8 is what? So negative 18 plus 8, negative 10. Okay, and then do you guys want to write what we're going to do for row 2? Because we want to change the row 1 and row 2. We're not going to be changing row 3. Row 3 is going to stay the same. Okay, so we're going to do the opposite. So it's 4. So we'll do negative 4 times row 3 plus row 1. And that's going to go in, or sorry, not plus row 1, plus row 2. And that's going to go in row 2. Okay, so see how similar these are? You're just doing the opposite of row 3. You're adding it to the row, and then it's going to go in that row. So this would be 0 plus 0, so it's still a 0. 0 plus 1, still a 1. Negative 4 plus 4 becomes 0. A negative 4 times negative 2 is positive 8. 8 plus negative 3 is going to be a 5. Okay, so then look, all we have here now, in the first row, it tells you what? What does the first row tell you? X is equal to negative 10. Okay, because the first column is X. This is your Y. Y is 5. Z is negative 2. And yep, it's exactly what we got using back substitution because it is the same system. Okay, so just by doing 2 more steps, you can put this in reduced row echelon form and you can pick out your equation right away. Okay, I'm going to apologize in advance for this passive-aggressive paragraph. I wrote this before ChatGPT was a thing. So you can actually use your calculator to check. So there's a function in your calculator where you can put them in that form. And I am going to share it with you tomorrow so you can check your work quickly. But I do just want to remind you that you have a Chapter 10 test where you won't be using a calculator. And of course, for these, you do have to show your work. Okay, so make sure you use your calculator responsibly. And then all we've been talking about so far are the one solution systems. But if you remember solving systems of equations, there were multiple different types. So there's inconsistent and dependent systems. And yes, this should have been on the next page. So sorry about that. Okay, so for the inconsistent and dependent systems, we're going to have not only one solution, but you could have no solution. Do you guys know what the last type is? There's one solution, no solution, or infinite. So infinitely many. Okay, so when you have it in row echelon form, you can determine which one of these systems you have. So if you are in a no solution situation, you will have a row that represents 0 equals some constant, okay? And that is not true. So it's no solution and it's called inconsistent. Okay, we're going to look at that below. So when we say 0 equals some value of C, it would be like this one here, this first one. So see this last row? Remember how this is the X, this is the Y, this is the Z, but you don't have a leading 1 there. So this last equation, this in this last row, tells you that 0 equals 1. That is not true. 0 is not equal to 1. So when that happens, that's how you know there's no solution. And then we call that inconsistent. Okay, and then the next one is one solution. Thank you. Okay, and if you have one solution, then each variable in that row echelon form is a leading variable. That's the type that we've been practicing where we're using that back substitution. Okay, so when they say that leading variable, okay, what that means is that it corresponds to a leading entry. Okay, so the leading variable is one that corresponds to the leading entry. And so here, each leading variable is going to be a leading variable. So for example, this row means x plus 6y minus z equals 3. This row is y plus 2z equals negative 2. So this is a leading variable, this is a leading variable, and then you have z equals 8, that's a leading variable. So when you have this system where you can use back substitution, that's when you have one solution. That rhymed, not on purpose. Okay, so if you can use the back substitution, there's going to be one solution. And then the last type is the infinitely many. So if you have the infinitely many solutions, okay, the variables are not all leading variables, and this would be called dependent. So they are not all leading variables. It is called dependent. Okay, and this is a lot of words here. It's a lot easier to just look at your matrix. And here, if you look at the last row, okay, you have all zeros. What that means is 0 is equal to 0, which is a true statement. That's why there's infinitely many. Okay, because you don't have that leading 1, and because you don't have that leading 1, it produces a true statement. You do have that 1 there, or any constant, then you'll get a false statement. Okay, and we call that dependent. All right, so your homework for today, 10.3, is the same page as yesterday. Now, this first set of problems, this 12 through 18 evens, you're doing parts A and B only. And the 12 through 18, it's just asking you to identify, is it in row echelon form, reduced row echelon form, or neither? Okay, so those aren't the ones where you're like writing out the matrices. Okay, the ones where you're writing out the matrices, you'll have 4 of those, which I hope will go a little faster than yesterday just because you practiced it yesterday. So I'm hoping it'll get a little easier each time, a little quicker each time. Okay, and then I'll give you the rest of today to work on that.